Welcome to the McAfee Center Stage webinar series. My name is Nick, and I will be your host. This webinar is a brief overview covering common use cases and scenarios regarding this topic. It is not intended to be all-encompassing. If assistance is needed, please contact McAfee Technical Support. Our speaker today is Jeremy Stanley. Jeremy is a Master Technical Support Engineer with over 14 years of experience. He primarily supports ePolicy Orchestrator and the McAfee agent and specializes in SQL and the ePO database. Jeremy is also based out of Plano, Texas. Ladies and gentlemen, Jeremy.
Thanks, Nick. So today in this webinar, we're going to go over basic database maintenance in ePO. So how to maintain the ePO database. So the first thing we're going to cover is the major schema differences between ePO 5.9 and 5.10. There is a major difference there that we will cover extensively. There we will cover how to properly purge data from the ePO database, how to maintain your indexes, how to identify database space issues. And we'll spend quite a bit of time on that because it can be tricky sometimes when your database is large or when you run out of space. It can be tricky to figure out exactly where that space is gone or what the problem is. And we'll show you how to go about doing that. We will talk about shrinking the database, and we will cover an issue that might be new to you called orphaned or reverse orphaned events that directly relates to the schema differences between 5.9 and 5.10. So those orphaned and reverse orphaned events issues will only occur in an ePO 5.10 database. So as I had mentioned, there is a big schema difference between ePO 5.9 and 5.10. Primarily here, the events database in ePO 5.10 is now its own separate database. So there's your primary ePO database that holds all the stuff that the ePO database has always held, you know, your policies, your settings, things like that. But your thread events, and not all events, specifically your thread events, are now written into a separate database. Now, it's only the baseline thread events that are written into the separate database. All of the extended event information that various point products have are still contained in the primary database. And so how do we tie these things together? Well, the answer is there is a synonym. This is a concept in SQL in the primary ePO database that points to the thread events database, specifically to the ePO events table in the thread events database. So what does that mean? That means if you go into if you run a query in your primary ePO database against select asterisk from ePO events MT, even though that table does not exist in the primary database, it will query the events database using this synonym. Another important thing to remember here is there is something called the ePO events reference table in the primary database. Now that table is literally just a listing of all of the auto IDs that are in the thread events database. And the purpose for that table is so that all of the extended events tables can have a foreign key reference. So if you don't know what a foreign key is in SQL, it's a pretty simple concept. It just means that a table has a particular column that references a row in a different table, and that would be a foreign key. So you can't foreign key to a totally separate database or through a synonym. And so for that reason, we have the ePO events reference table that has all of the auto IDs in the events database, and that allows the extended events tables to continue to have their foreign keys. And we will cover this a little bit more towards the end of the presentation. Okay, now that we've covered the schema differences in the database between ePO 5.9 and 5.10, I want to talk about purging data. Now, it is very important that you purge out old data from your ePO database based on your company's data retention period. Now, I don't know what that might be. It's different for every company. Some companies are required to keep thread event data, for example, for a year. Others might offload that data to a SIM, and then they only keep it in their ePO database for a couple of weeks or maybe a month. So whatever your data retention period is, you do want to make sure that you start purging out data older than that period from your database. If you do not, then over time your ePO console can become sluggish and slow, and your database will become very large. So there are 2 KBs referenced there. One of them shows you how to set up purge tasks using maintenance tasks inside of ePO. And that we definitely recommend that you do as opposed to directly purging via SQL. Now, if you have to, for some reason, directly purge data via SQL, the bottom KB there will explain to you how to do that. I'm going to demonstrate how to do it in ePO here in just a moment. Now, once you've purged data from the database, it is also equally important to make sure that you maintain or defragment your indexes. So an important concept to remember in SQL is it does have indexes that improve query performance, and the act of inserting data to or deleting data from the database fragments these indexes. So for that reason, if you run a task to purge a whole bunch of data on the database, it's a pretty good idea after that task runs to run another task in order to defragment those indexes. Just like failing to purge out old data, if you fail to maintain your indexes over time, your console performance will be impacted, your ePO console will just run slow, and it can even lead to failures such as event inserts failing because they reach timeout period and they can't be inserted in a timely fashion. So we do have a server task for this, and there is also, which I'm going to demonstrate how to set up the server task. You can also do this via a SQL job, and we have a knowledge base article listed there at the bottom, KD 67184, that will show you what script you can use to do this directly via SQL if you have to, and how to set up a SQL job for that purpose. So now I'm going to go into a demonstration on how to do these tasks in ePO. So I'm now going to demonstrate to you how you can set up a server task to maintain your ePO database. So the first thing you would want to do is come over here to the server tasks. All right, so I'm just going to clear those tasks out. So I'm going to create a new server task, and I'm going to call it ePO database maintenance. I'm going to say next. So in the actions drop-down list, you're going to want to find these tasks that say purge. And the first one you're going to want to run is the purge threat event log. Now you're given a couple of options here. You can purge based on query, which basically means you write a table query that returns a list of the events that you would like to purge, and it will just purge all of those. But the more common option for this purpose is to purge based on how old the records are. So it's very important. Any ePO server over time is going to have more and more events written to the database. And if you do not start purging out the old data, eventually you will end up with way too many events in your database. So for the purge records older than, I'm going to put in 30 days. Now this is really whatever your data retention period is. If you're required to keep data for 1 year, then you would just select one year. In this case, I'm going to say 30 days. Now, a very powerful feature of ePO server tasks is the ability to chain multiple tasks together. So you don't have to create an individual purge task for every single purge type table that you might want to purge. So down here, I'm going to just hit this little plus sign, and it gives me another action. And I'm going to run a purge client events. So client events are similar to, but different from threat events. Client events are things like data update succeeded, product deployment failed, whereas threat events are malware or other types of threats detected by endpoints. So same options here. I'm just going to purge client events older than 30 days.
And I'm going to select. Now the selections I have here are not exactly random. I'm going to show you the things that every ePO server should set up. You need to have a task set up to purge all of these rows on every ePO server, because every single one of these rows is going to grow over time. So it's these four are the primary ones you're concerned about. Thread event logs, because clients are always going to generate thread events. Client event logs, because clients are always going to generate client events. Server task logs, because your server task log in ePO is always going to get new entries written to it. And the audit log, because your ePO server will always generate more entries in their audit logs. Now, there are many other options, purge options you can choose from, based on what product extensions you have checked in. So, just to give you an example, solid core. If you're using solid core, you might want to add a solid core purge to the list. I think I have, here's one up here for threat cleanup task for CWS. So if you're using CWS, you would add this task. So the others are more based on whether you're using them or not. But every ePO server will need these four. So then the last thing I'm going to do in this task is to maintain the indexes. Right here, ePO database index maintenance. Now this order is important. So if you recall, anytime you write to or delete from the database, you are fragmenting the index. So it makes sense after you purge a whole bunch of data that you would then run a reindex task in order to, because these purges are imparting fragmentation on the index, and then you run a reindex task to reorganize the index, defragment them, and make sure that your console performance remains good. One thing to remember when you chain tasks like this, if it does the tasks sequentially, so it will do this task, and when this task completes successfully, it will move on to the next one. Now the key word there was successfully. If it gets down here to purge, say, the server task log, and this fails, it will not move on to purge the audit log. So so it is important when you chain your tasks like this, because you are introducing some fragility, that you monitor the server task log and make sure that that task is succeeding. If you see that it is consistently failing on one of these actions, then you would want to remove that action from the task and maybe set up a separate task to complete that action in order to make sure that all of your other purge tasks complete successfully. And just set it up in a separate task until you can figure out why it's failing and get that resolved. Now, the last one is the database maintenance, and it is important that it does these sequentially because you do not want to reindex your database while you're purging from the database. That will almost certainly result in a deadlock and one of the two tasks being chosen as a deadlock victim and failing. So if you do want to separate your database maintenance task, your reindexing task, in its own separate server task, just make sure that you schedule that in such a way that it does not overlap in time or does not run while any of your purge tasks are running. Okay, so I will talk briefly about scheduling. In larger environments, you will want to run these purge tasks with a greater frequency, like maybe even several times a day, but at least once a day. What you don't want to do in a very large environment, like an environment with 100,000 or 200,000 endpoints, is to purge once a week. Or at a less frequent interval. The reason for that is if you have 200,000 endpoints managed by ePO, they can generate quite a lot of events in a week. And if you run that purge task only once a week, it's going to take a very long time to complete. And the longer it takes to complete, the more likely it is that it's going to run into a problem and fail, such as a deadlock or something along those lines. So by purging more frequently, you can make that purge task complete in a shorter period of time and increase the chances of success. So I'm just going to leave the schedule like that for now, and I'm going to run it really quick. Run this one right here. So when I run it, it will jump me directly to the server task log, and you can see here where you can track the progress. Now, this is where you would tell. Now, in this case, it's already completed successfully. There wasn't really much to purge. You can see it tells you how many records it purged. Because I don't have any events older than 30 days, it didn't purge any events. What you can see here is if it's failing, it will tell you exactly which action it was failing on. So that will tell you which one you need to go and remove from the task until you can figure out why it is failing. Okay, so that is everything we have on ePO maintenance.
Okay, so now let's move on to another common problem, which is that your database is running out of space or your database is too large. Now, this could be just simply because you haven't been running your maintenance tasks, in which case your job is easy. Just follow the guidance previously given to set up your maintenance tasks, and then that should clear that issue up. But let's suppose that you've been running your maintenance tasks and they've all been completing successfully, and your database is too large or your database has run out of space. So we're going to go through some steps on how you can identify what the problem is. Now, keep in mind, if you get an error that says your database is out of space, it may not be that the database itself is the problem. It could be that the partition hosting the database is running out of space. And we'll show you how to fix that in a demonstration, or how to identify that in a demonstration. It could also be that your database size has been restricted, or there could have been a particular event that caused one of your tables to grow really large in size because it just kept getting a whole bunch of information dumped into it. Now, if you actually literally run out of space on your database and you cannot insert any more data into the database, the result of that will be you will lose access to your ePO console. This is one of the few places where we not only recommend, but you must correct the problem directly in SQL. And we have some knowledge base articles referenced there at the bottom, KB 93031 and KB 76720, which can help you go through many of these steps if you don't have access directly to the ePO console. I am going to demonstrate what you can do through the ePO console to identify and resolve database space issues. So while we're talking about database space issues, a common reaction that many people will have when they encounter these problems is just to go out and shrink your database. That seems like the right thing to do, but in many cases, in most cases, it is not the right thing to do. Keep in mind that if you shrink the database, this has a negative impact on performance. When you shrink the database down, when ePO writes new information to the database, SQL will then just have to regrow the database. And that act of regrowing the database it imparts a performance impact and can cause your console to run a little bit slower. So there's really only one scenario where you should shrink your database. And that is if you've identified some singular event that caused a huge amount of information to be written to your database and caused the size of the database to grow much larger than it normally would. In that scenario, after you have identified and resolved that issue, then you would want to go in and do a one-time shrink on your database to get it back down to a normal size. So what could that singular event be? Just as one example, you might have gone into your ENS access protection rule and turned on reporting on a rule that is very noisy. And then now all of your endpoints are constantly flagging this rule and sending up an event, and it causes your events database and your primary database as well, because this can be included in extended event information, to get very, very large. And in that scenario, you would want to first identify what is causing this float of events, correct that problem first, and we're going to show you here in a moment exactly how you can go about doing that. And then once that problem has been corrected, you might consider a one-time shrink to get your database size back down to a normal size.
Now I'm going to demonstrate some methods that you can use to identify why your ePO database is either out of size or why it's really large. So the first thing I'm going to do is I'm going to walk you through this knowledge base article. This is KB 79561. And right here at the very top of the knowledge base article, it gives you some instructions on how you can go into your ePO console and access this server informations page, which will give you a wealth of information on how big your database is, what its growth settings are, and what tables are taking up the most space. And I'm going to focus a little bit more on that. Now, don't worry, I'm going to demonstrate all of this stuff to you in the ePO console. I'm just going to show you some stuff that's in the KB first. So if you look at this largest tables section and you identify that there's one of the tables in your database that is taking up the most space, well, then you can come down here to these solutions, and it will tell you based on the table name. So these are table names. What the actions are that you can take in order to purge data out of that table. So that's all fine and good, and that's super useful if you have access to your ePO console. One of the problems is many times when your database runs out of space, you lose access to the console. If ePO can't write to its database, then you cannot log on to the console. And this other knowledge base article gives you much the same instructions. This is KB 76720. It gives you much the same instructions, only tells you how to do these steps directly in SQL. So you can see down here, this is a query that when you run it, it will list out your table names and how much space they're using and how much free space they have. And it has much the same information where you can then find the table that's causing you problems, and then it will give you instructions on how you can what queries you can run directly in SQL in order to purge data from that table. Now, I would always recommend that you do this directly in the ePO console if you can. So I would only use this knowledge base article as a last resort if you've lost access to your ePO console. Similarly, this knowledge base article, KB 93031, will show you how to check your SQL auto growth settings, your partitions, the partition hosting the database, and things like that. Now, these are all things that you can easily find, as I'm going to demonstrate to you in a moment, in the ePO console. But if you don't have access to the console, you can use this to figure those things out. I'm not going to demonstrate all of the doing all of these actions directly in SQL, but I will walk you through how to do it in the ePO console. As always, if you have a problem with your ePO server and your console is down, and you don't feel comfortable going through all of these steps yourself, you can always open up a ticket with support, and we will be glad to assist. So let's get started by walking you through some of these steps in the ePO console. And it all starts with going to this server information page. So if I come over here to the ePO console and I go to menu and go to server settings. And here, just search for server info. There's server information right here. So lots of very useful information on this page, but what we are going to look at is right here, this largest tables. So if you look through this list, now it's ordered by the size of the table. Now, because this is just a test database, the largest table in this database just is my snapshot table, and it's not even all that large. But over here is the table name, and then this is the size of the table, and then it just goes down in descending order from there. So what I'm going to focus on for now is the EPE extended events table. Now, this is an extended events table for the for ENS, and in this specific example, it is not all that large, but it is commonly one of the larger tables in the database. And I'm going to demonstrate how you can identify why that table might be large here in a moment. But before I navigate away from this page, I want to show you some of the other very useful information that you can find on here. So if you come up here in the database information section, you can see it tells you right away how big your database is, how much free space your database has, how much is in use, and what your transaction log is, all this good stuff, which is helpful to identifying why your database might be large or where it might reside. Now, if you come down here, you get much the same information, only it's talking about the individual files. So now in this case, there's only two. So if I just tick this, so you can see now I'm on the data file. This is the primary file of the database, the MDF file that has all of your data in it. And then if I tick it down one, we have the log file, which is the transaction log. Now, one of the useful things that this tells me is what partition, in this case, the C partition, what partition the database file is located on. And that is important because if you're actually out of space or running out of space, it might be because the partition that is hosting the database is running out of space, in which case maybe you could go onto that partition on your SQL server and delete some other items in order to free up space. Now, if you scroll over here, it gives me much that same information. It tells me I'm going to go up one tick and look at the data file. It tells me that, I have 4,040 megabytes in total space in my data file, and 83 of it is free space. Free space basically means empty. It's not being used. And then we have a free space percent. Now you might think, oh no, 3%, that means I'm almost out of space. Not exactly, because of these two settings. So what the free space means is it basically means I have, in this case, 83 megabytes of space that is not used. And if I write information to the database and I get to the point where I need 84 megabytes, I need one, a little bit more than what I have, what SQL will do is pay attention to your file growth setting. And if your file growth setting is set to 64, and it's set to unlimited growth, that means as soon as I run out of space here, it will then allocate 64 additional megabytes of space to the database, and you'll have more free space then at that point. And this just tells you as an absolute cap on how large your database can grow. So if your database has grown, if your database has reached whatever this cap, in this case it's unlimited, then it will no longer allocate any additional space. Now, obviously, it can't be unlimited. It's limited by how much space you have available on the partition. So if you're running out of space and you see that this is unlimited, then almost certainly the problem is going to be that the partition hosting the database is out of space. And at that point, you either need to reduce the size of your database or allocate some more space to that partition or otherwise free up space in that partition. You get basically all of the same information down here. I'm not going to go through it all again, but it's all the same principles, only this is for the events database. If you recall, in ePO 5, 10, and newer, the events database is on a totally separate database. So let's suppose, remember I said earlier, we were going to revisit the EPE extended events. So let's suppose for this exercise that was this table using up the most space in your database and you wanted to free some of that space up. So what you could do is come over here to queries and reports. Now remember EPE extended events, if you look on this knowledge base article, we had already determined that EPE extended events was a threat event. So you would need to purge from the threat event log. So that means over here, I can run a query to try to determine what is taking up all of that space. Now I already have some queries that I've created. Right here in the shared queries. The first one we're going to look at is this multi-group summary threat events query. So I'm going to hit the edit button here. I'm going to walk you through how this query was created. So the first thing we want to do is go back over here to the result type. So because the EPE extended events table is a threat, one of the threat events tables, in order to purge data from it, you're going to have to write a query that looks for threat events. So if you go over here to the left and select events and then select threat events. So not client events, those would be a different table entirely. All right, so from there, you can use any number of charts here in order to figure out where your table space is going. I'm using a multi-group summary table. And the way that I've done this is I've set the table up to group all of the events based on the number of events here, based on the label threat names. Whatever all of the events with the same threat name will be grouped together. And then I further have, because it's a multi-group, not a single group, the other grouping is based on the host name. Now, there's any number of ways that you could divide this up or use one of these other queries. What the goal here is to find the most common, or try to find where all of your space is being taken up. So, for example, you might group them by event ID in order to figure out which event IDs are the most common. That might be another way to do it. So I'm going to come over here, and the next is the columns. This is not all that important for this purpose. This is just the columns that will be displayed if you drill down on the table. Now the filter in this case is nothing because we don't know what we want to filter on. So let's run this and see what it looks like. So in this case, I can see that I have a threat name of iCar test file. Remember, this is just a test database. So I just generated some test detections in order to get some event data in here. So I don't have any other threat events, but normally you would actually have several different threat events. And they would be ordered by the most numerous, right? So you would then look and say, okay, well, this iCar test file in this case is the most common. And then you might even look further and you could say, hey, look, this machine has got half of all of the threat events are just from this one machine. So maybe something happened on that machine that caused a spike in threat events, and that might be what you zero in on. Again, this is just an example, just to show you how you can build these type of queries. In the real world, you would probably use something like threat event or some other criteria other than the host name, but in this case, it'll serve well as a demonstration. So in this case, I've identified, okay, my database is large because of these iCar test events and because of this one particular client is what's generating about half of them. So what do I do next? Well, so you take that client name, and what you can do is create a query to identify specifically the events that you want to remove. And I've already done that here, and let me show you how that query looks. So again, the result type is events, threat events, just like in the previous query. And over here, the result type, how we're going to display the results is not a multi-group summary table. It is just a table. A table is just a listing of events. And the reason is, we are going to show you in a moment how you can create a server task to purge based off of this query. Now, for that to work, it must be a simple table query. And the reason is, if you used, say, a pie chart, the server task would not know what slice of the pie chart you want to purge events from. So instead, it uses the table query, and then that will just purge everything that shows up in that table will be purged from the database. So again, the column selections, not all that important here. And if we come over here with the filter, this is what you will want to set up very carefully to make sure that you are only selecting the events that you want purged. So in this case, remember I said, hey, it's this one machine, JSSD-Win10, that is got over half of all of my events. So I want to make sure that I target that machine, threat target host name equals the machine name. And the threat name that seems to be taking up the most space is these iCar test files. Now, I could use event ID instead, or I could say, well, I don't want to purge them all. I only want to do them, if the event was generated not within the last 30 days, right? It's really any combination of things here will work as long as it's identifying the specific events that you have found that you want to remove from the database. So let's go ahead and run this, and you can see it will just return these 1278 events that are iCar test files for this one host, and we have 1,000 229 of them. So you can look through that and make sure you're happy with it, and make sure that it is actually displaying the events that you want to purge. So once you're happy with your query, the next step is to come over here to the server task log. So I'm going to come into server tasks, and I'm going to say purge just to reduce that list. Okay, so I'm going to create a new task, and I'm going to call it purge ICAR events for JSSD when 10, because that's what it's going to do. I'm going to hit next. Okay, so we don't want to run a query. We want to come down here and select the action type of purge threat event log. So from there, we're going to select purge by query, and we are going to select that query that I mentioned before. So what this will do is it will run the query, and then any event that shows up on this query, it will purge. I'm going to go next. The schedule doesn't matter because I'm going to run this right away. I'm going to save it. So here is my query, and I'm going to go ahead and kick it off. So this takes me to the server task log. It is already completed. You can see it purged 1,229 events. So that's great. So let's see then if that has addressed the problem. So if I come over here and I go into back into queries and reports, if I run this report now, it should look quite different. So you can see I only have 3 machines. That other machine is missing entirely, and I have roughly half the number of events as I had before. And this query over here should now show as empty. And it does. Now let's go back to our server information page. Okay, here we are on server information, and if I come down, now I want to show you what that has done in a couple of places. First of all, let's look at the EPE extended events table. So that table is a bit lower. Here it is. And what you'll notice, first of all, is this had over 2,000 rows before, but now we're down, we've reduced it by 1,000, so it's gotten smaller. Now, one thing you will note is my database size hasn't changed. It's exactly the same size as it was before. And you might be saying, hey, didn't you just delete a bunch of stuff? Well, I did, but the way SQL works is it does not actually free up that space immediately whenever you purge the events. It just frees up space in the inside of the file. So instead, before I believe I had 2%, or it may have been 3%, but basically I've added more free space in here. So you can still write data to the database without it having to grow. Now, in this example, this is a very small test database. Normally, if you're going through this exercise, you're going to be purging a much larger volume of events. The purge will take much longer in time. It could literally take hours or even days if you're purging, hundreds of millions of rows. And you'll have a very sizable difference in free space after purging that much data. So the other things, if purging data doesn't work, or if you have purged all of your data and you still have a size issue, you might need to shrink the database. As I had mentioned before, you generally speaking do not want to shrink your database. The only time to do that is if you have identified some singular event that caused your database size to grow really large, and you just want to then shrink the database after that. In that scenario, you could run a one-time shrink. That's something that you have to do inside of SQL. We have information on the bottom of really every single one of these articles about shrinking your database here, and it gives you the command that you can use in order to shrink it. You just have to plug in the correct database name. Okay, and that is the end of this demonstration.
Okay, so now we're going to talk about orphaned and reverse orphaned events. Now, these are just terms that we have invented to describe a relatively common problem that occurs in ePO 5.10. Now, everything I'm going to give you here on this slide only relates to ePO 5.10, and it is a direct result of the schema change that I had mentioned between ePO 5.9 and 5.10, where we now have our events in a separate events database, our thread events in a separate thread events database. So first, let's talk about what they are. An orphaned event means that there is a reference to the event in the primary database, in that ePO events reference table, but there is not a reference to the event in the thread events database. Now, how does an orphaned event happen? It almost always happens because someone has been using a purge query that was originally written for ePO 5.9, not one of our refreshed or updated purge queries, to directly purge thread event data via SQL. And that purge query does not account for the fact that the corresponding events need to be removed from the ePO event reference table, and then therefore it creates these orphaned events. Now, why is that so important if you have one table that has some references to it? Well, it's important because our extended event tables, if you recall, I had mentioned they have foreign keys going to the ePO event reference table because they cannot point directly to the thread events database. Now, those foreign keys have a special property known as cascade delete. So what does that mean? So we'll take one example. We'll talk about the extended event, the EPE extended event table, which is just one of many extended event tables that we have. That one is for the product ENS. That foreign key, which points to the ePO event reference table, has the cascade delete, and what that means is if you delete a row from the ePO events reference table, which is referenced in the extended events table, the corresponding event rows will also be deleted from the EPE extended event table. So you only have to delete from one table, the ePO event reference table, and it will take care of all of the extended event tables via this foreign key. But if you've been deleting directly from the events database and not deleting those corresponding rows, all of those other tables, all of that extended event information will remain in the database. So that is an orphaned event. So what is a reverse orphaned event? That is the exact opposite. It means that the events are in the thread event database, but there is no corresponding reference to them in the ePO event reference table of the primary database. How does that happen, you might ask? The primary way that happens is if you restore your primary database to an earlier copy, but do not restore the threat events database from a backup copy taken at the same time. In that scenario, the primary database will lose the references in the ePO events reference table, but those references will remain in the ePO events table. In the thread events table, I should say. For both of these issues, we have a knowledge base article, KB 93761, which provides scripts that can show you how to identify that you have orphaned or reversed orphaned events, and they also provide scripts on how to clean them up if they exist. So that is the end of my presentation. Over to you.
Thanks, Jeremy. As a reminder, McAfee Education Services offers exceptional training to go along with our award-winning products. If you would like to learn more, please visit the website listed on the screen to see all of our offerings. I want to thank everyone for joining today's webinar, and a big thank you to our speaker, Jeremy. This concludes today's webinar. Stay safe, everyone.